Hello everyone, I am Dr. Fawzul Atiq. I am giving some series of lecture for the course Probability and Statistics. In the last lecture, we have discussed about the discrete type random variable, right? And from today's lecture, we'll discuss about a particular type of discrete type random variable. And let us see what is that. So first we'll discuss about a Bernoulli trial. What is a trial? A trial is kind of an experiment where you will multiple time you will do that experiment, right? And where probability of success is independent, correct? So trial is such kind of experiment. Whereas Bernoulli trial is what? A Bernoulli trial is a random variable with exactly two possible outcomes. One is success and failure. And the probability of success, it is denoted as P. It is remain constant. So probability of success, it is denoted by P, and it is remain the same for each trial. And the probability of failure, which would be definitely 1 minus P, because probability of success is P. So this will also be constant, right? So if you have the Bernoulli trial, then the random variable, suppose X is the random variable, which is the Bernoulli trial. Its outcomes is the it is a random experiment, and the random variable takes the Bernoulli trial's outcomes. So if you get the success, you will say X is equal to 1, and if you get the failure, you will say it is X equal to 0. So the random variable takes the value either 0 or 1, this two one. Then if you think about the probability mass function of this random variable X, what will happen? So P of X is equal to 0, which is actually small p of 0 is equal to what? It is the probability of success, which is already given, which is small p. And P of 1, sorry, P of 0 is actually 1 minus P, right? So I should say it is P of the success is actually P of 1. So if you get the success, we'll say it is 1, X equal to 1. So this is P. And if you get the failure, we'll say it is 0. So P of X is equal to 0. And that is 1 minus small p. Now both the things together, we'll write it in this way, that P of X is equal to maybe small x is equal to small p into, how can you write down? Maybe I'll show it to you. Both the things together will show you in this way, that P of X equal to X is equal to P to the power X into 1 minus P whole to the power 1 minus X. See, this is actually, just put P of X is equal to 1. What will happen? It is small p to the power 1 into 1 minus p to the power 1 minus 1, which is 0. So this is p only, right? So whatever we have written, that one we can together write as a probability mass function. Similarly, P of X equal to 0 will give small p to the power 0 into 1 minus p whole to the power 1 minus 0, which gives you 1 minus p. Right? So both the things together we can write at P of X is equal to P to the power X into 1 minus p whole to the power 1 minus X, where X is equal to 0, 1. Correct? So this is the probability mass function of Bernoulli trial. Now, what are the properties of it? Each trial has only two possible results. One is success, another one is failure. Again, the outcome of one trial does not affect the outcome of any other trial. So they are independent. So the outcome of the previous trial is not affecting the outcome of the next trial. So they are independent. Next, because you are multiple time doing this experiment, right? So the probability of success P is the same for every trial. So these are few properties of the Bernoulli trial. And example, yes. So if you flip a coin, then we all know that either it will come as head or tail, head or tail. So you may think that, okay, your success means if you get the heads, so probability of success is 1 by 2, right? Now, if you flip the coin 2 times, so does the second time flipping, whether it will be coming as head or tail, does it depend on the previous one? No, right? So therefore they are independent. And each time probability of getting head, which is in our case probability of success, is 1 by 2, which is P always same. So all this kind of events are Bernoulli trials. Even if you just roll a die, rolling a die, you can again consider it as a Bernoulli trial. How? Just you have to define that what is your success. So if you define that your success means if you're getting the phase 6 in case of a die, then it is success. Otherwise, all the cases it is failure. In this case, probability of success is what? Small p is equal to, it is 1 by 6, right? And then again, if you experiment these things multiple time, every time probability of success is 1 by 6 only. And it is either 1 by 6 or not 1 by 6. So you can consider it as a Bernoulli trial again, right? Again, manufacturing like a product, if product being a defective or not defective. Yes, if you manufacture a product, either it can be defective or not defective. If you make the success as okay, if it is defective, you will say it is the probability of success, it is the success. So it will have some probability. Otherwise, it is not a defective piece. So again, you may consider it as a Bernoulli trial in this case as well. Okay. Next is our probability mass function. As we have already discussed, the probability mass function is this one, that p of x is equal to p to the power x into 1 minus p whole to the power 1 minus x. We have already discussed this part. Then we can also calculate the expectation of the Bernoulli random variable, right? X with the like x is the random variable which represent the outcome of the Bernoulli trial. So in this case, expectation of x we can easily calculate. How to do? So we all know that expectation of x is actually equal to summation of x into small px. But what is small ps? It is summation of x into capital P of x is equal to x. So it is summation of that value. So x is what? Whenever x is equal to 1, its probability is 1, plus whenever x is equal to 0, its probability is 1 minus p, which is q. So altogether it gives you p. So the expectation of x is p, right? Which is basically the probability of success. Now, how to calculate variance of this random variable? We all know that variance of x formula is E of x. This variance formula is E of x square minus ex whole square, right? Now, what is E of x square? Again, we can easily calculate. It is summation of x square into p of x. So x square means what? 1 square into p plus 0 square into q, which is what? Which is again small p, right? Therefore, variance is equal to E of x square, which is p, minus ex square, which is p square. So p into 1 minus p, therefore p into q. This is the variance. of the Bernoulli trial. So therefore we got the variance of the Bernoulli trial is equal to P into Q, and expectation of the Bernoulli trial, that random variable, it is small p. Clear? Okay. Now we'll discuss about the binomial random variable. Now a binomial random variable represent the number of successes in a fixed number of independent Bernoulli trials, where each trial has the same probability of success. We all know in case of a Bernoulli trial that each trial has the same probability of success. So binomial random variable is what? It represents the number of success in a fixed number of independent Bernoulli trials, right? So suppose that a random variable x follows a binomial distribution if it counts the number of success in n independent Bernoulli trials, where each trial has a success probability p, and it is denoted as x is actually equal to bin n comma p. That means you have x represent the number of success in n independent Bernoulli trial, where n is the number of trial, p is the probability of success in each trial, and then 1 minus p should be the probability of failure in each trial. So what should be the probability mass function of it, of the random variable x? So first let us understand that the x is what? It is the number of success in n independent Bernoulli trials. So this random variable x takes which values? So you have n independent Bernoulli trials. You may have the number of successes 0 among these n possible. Number of success may be 1, maybe 2. It can goes up to what? Number of all n can be the success. So x will take the values as 0, 1, 2, and it can goes up to n. Correct? Now we will calculate that if x is any particular value from this set, what will be its probability? That means we will calculate the probability mass function. So suppose in your n number of independent Bernoulli trials, you have first k number of trials are success, and after that they are failure. So we basically want to find the probability of x is equal to k. So you have n number of independent Bernoulli trials. Among them, what is the probability of getting k number of success? So we will try to find out this. So for that, we assume that I just want to explain that how to get the PMI, the probability mass function. So suppose the first k number of trials gives you the success. Suppose. So it is success up to first k numbers are success, and then all of them are failure. So how many failure will be there? N minus k number, because total number is k, right? So then these are all basically the independent event. And you know that independent means what? You can just, because they are the intersection. So independent means it is actually P of S into P of S, like this you will go into P of S k times into P of F failure up to n minus k times. But what is the probability of success? It is P. So how many times it is there? K times, right? So it is small p to the power k, and failure is n minus k times. But probability of failure is what? 1 minus p. It is 1 minus p whole to the power n minus k. Now this one we just got it for the first k number of trials we got the success. But this may not be the case now. Only you may have the success, you can have it in any places, this k number of success, right? So first one may be failure, second one may be the success. third one may be failure, fourth one may be the success. In this way, this k number of success can be anywhere between this n number of trials, correct? So this k number of success, you can get it among this n number of trials. So how many ways you can get it? It is the combinations, right? So n into c, n c k ways you can find out. So therefore, probability of x is equal to k is actually n c k into the success probability, k number of success. So n c k ways you can have this success, and probability of success is small p to the power k into 1 minus p whole to the power n minus k, where this k can be any number between 0, 1, 2 up to n. So this will gives you the probability mass function of this binomial random variable. Clear? So therefore, the probability of obtaining exactly k success in n trials is given by p of x is equal to k is equal to nck p to the power k into 1 minus p whole to the power n minus k, where k is from 0, 1, 2 up to n. And nck is the binomial coefficient, we all know, that is the n choose k, right? So this is the probability mass function. But how do you verify that this is the probability mass function? But we all know that if random variable takes this value, so their probability sum should be 1, right? So let us see whether it gives you the sum is 1 or not. So summation of k equal to 0 to n, p of x is equal to k. What it gives? It is equal to summation of k equal to 0 to n, nck into small p power k into 1 minus p whole power n minus k. But can you recognize this formula? Yes, it is the binomial theorem, binomial expansion. We all know. So this is actually equal to p plus 1 minus p whole to the power n. So it is actually 1 to the power n, and therefore it is 1. So what we got, the sum of all this probability, p of x is equal to k, k equal to 0 to n, it is 1. Therefore, it is the probability mass function. It is verified as well. Clear? Okay. So yes, which confirms that the total probability sum is 1. So for this binomial random variable, we can find its expected value of the binomial random variable. But how we calculate the expectation, we all know. So expectation, how to calculate? So expectation of the this binomial random variable is equal to, but first of all, it is expectation formula, x into small p of x. This is the expectation formula. But what is small p of x? It is summation of x into capital P of x is equal to small x, correct? And x is taking the value 0 to k, right? Now what is this probability mass function? We'll put that value. What was that? It is summation of, maybe I'll write down the k equal to 0 to, sorry, it is x is equal to 0 to n, right? So we can write maybe what we'll do, because we took the value as k, so I'll just change the and this index by k, so there is no difference. So what I will do, I'll change the index by k just to match with our thing. So it is summation of k into p of k, which is k into summation of x is equal to k, because we have written in this form. It is k equal to 0 to n, right? And therefore k equal to 0 to n, this value is k into nck p to the power k 1 minus p whole to the power n minus k. We can write in this way. Now, once we put the k equal to 0 value, this whole sum, the first term will be giving you 0. So I can certainly discard the k equal to 0 value. So I am taking summation of k equal to 1 to n. Then k into n ck p to the power k into 1 minus p whole to the power n minus k. Right? Now, this term k into n ck, if you write it in somewhere else, it is k into n ck means what? N factorial divided by k factorial into n minus k factorial. So we can write this as k and k factorial, it is k minus 1 factorial. So n into n minus 1 factorial I can write in the numerator. Denominator is k minus 1 factorial into n minus k factorial. But this one I can write it as n into n minus 1 c k minus 1. I can write down. So therefore, this k into nck I can write n into n minus 1 into c n minus 1 c k minus 1. So therefore I can write k equal to 1 to n minus 1 c k minus 1 p to the power k 1 minus p whole to the power n minus k. Now what I can do, I'll take just 1 p common. So n is there and 1 p I'm taking it from here. So it is n into p, then summation of k is equal to 1 to n minus 1 c k minus 1 p to the power k minus 1 into 1 minus p whole to the power n minus k. Now what we can do, we'll change the index as that k minus 1 equal to, we are taking j. Now if k runs from, k is from 1 2 3 up to n, what j will run? J will run from 0 1 2 up to n minus 1. So therefore, after changing the index, we can write np into summation of j equal to 0 to n minus 1 into n minus 1 cj p to the power j into 1 minus p whole to the power n minus 1 minus j. And but this value is what? We have already seen this is a binomial theorem. It is p plus 1 minus p whole to the power n minus 1, which value is, so np into p plus 1 minus p whole to the power n minus 1. But this value is 1, this two can be 0, it is n into p. So the expected value of the binomial random variable gives you n into p. What is n? N is the number of independent trial and p is the number of, p is the probability of success in each trial. Correct? So we find the expected value of the binomial random variable. Now, if you look at the variance, we can get a similar kind of a technique to get the variance, right? So we have not done it in detail. So we can see that expected value of x square we'll calculate first. Then after doing this similar kind of thing, we'll get e of x square is equal to n into p into 1 plus n minus 1 into p. And if you put it in the formula, that we'll get the variance is actually gives you np into 1 minus p. It is actually npq. Q is 1 minus p. Right? So we are not doing explicitly the variance calculation, but in a similar way, one can do that. So you remember that if you have a binomial random variable, its expectation is n into p and its variance is npq. Clear? Okay. Now we will solve one example. So look at this example. I'll not show you the answer first. Look at this example. A fair coin is tossed 10 times. Right? Now see, what is our experiment? A fair coin is tossed 10 times. And let x be the number of heads obtained. What does it mean? So whenever we are tossing a coin, we will have only two outcomes. One is head, one is tail. And x is the random variable. It is the counts the number of heads. Therefore, what we are assuming that if you get the head, it is the success, right? So what is the probability of success in this case? Probability of success small p is equal to 1 by 2 is getting the head, which is 1 by 2. And this trial, it is actually a Bernoulli trial. And we are doing the Bernoulli trial 10 times. Therefore, x follows the binomial random variable, right? Then the question is, what is the probability that exactly 4 heads appear? Now, this is very easy. So, in case of that means x is what? Binomially random variable. It is binomial of n comma p. N is 10. 10 number of binomial trial you'll do. And probability of success is 1 by 2. Right? And then we all know that what is the probability mass function of Bernoulli random variable? So it is P of capital X is equal to small x. It is NC x small p to the power x into 1 minus p whole to the power n minus x, where x is equal to 0, 1, 2 up to n. But what is n? N is 10 here. What is small p? It is 1 by 2. Correct? So therefore, we have small p. This is the binomial n equal to 10 and small p equal to 0.5. Therefore, if we put it in the formula, p of x is equal to k, it is nck like this one. In this expression, we are putting n equal to 10 and small p equal to 1 by 2. So we'll get it is nck, that means 10 ck 0.5 to the power k, 1 minus 0.5 to the power n minus k. So this will gives you 10 ck into 0.5 to the power 10. Correct? Now the next question is, now the first question basically, what is the probability that exactly 4 heads appear? So therefore x value equal to 4, you have to calculate, right? So just put x k equal to 4. What we'll get if I put k equal to 4? So p of x is equal to 4. It is 10 c4 into 0.5 to the power 10. And if you calculate the value, we'll get it is 0.205. The answer for the first question is done. Next, what is the expected number of heads? Next question is, what is the expected number of heads? That means the we all know the binomial random variable. If it is there, what is the expected value of that? It is n into p, right? So if I do that n into p, the second question. So the second question answer will be that e of x, it is n into p, but what is n? It is 10. What is p? It is 1 by 2. So the expected value is 5. Next question was, what is the variance of x? So we all know that variance of the binomial random variable, it is n into p into 1 minus p or np cube. So n is what? N is 10. P is what? 1 by 2. 1 minus p is what? Again 1 by 2. So therefore it is 2.5. So this is the variance. Clear? So therefore we have this one, that yes, as we have already done, expected value is 5 and variance is 2.5. Got it? So finally what we understand that if we have some experiment where like n number of times experiment we will do, where each time one experiment is a Bernoulli trial, where each experiment will have either success or failure. Each experiment will have only two outcomes, either success or failure. And that kind of experiment we will do n number of times. So binomial random variable represent the number of success in this n number of trials, right? So whenever such kind of problems are there, we should be able to identify that where the limited number of trials, finite number of trials are there, n number of trials, and number of success you have to get. So definitely it will follow the binomial random variable, right? So most of the content of this lecture we have taken from this book. I hope you like the video. I hope it will be helpful for you. We'll meet in the next video where we'll discuss few more discrete type random variables. Thank you very much.